Welcome to our YouTube channel. In this video, we are going to do seismic load calculation based upon UBC standard. In the right hand side, you can see a PDF file which is showing 1997 Uniform Building Code. That is a UBC code which we are going to follow to calculate seismic load. In the left hand side, you can see an Excel sheet which is developed to demonstrate this seismic load calculation using 1997 of UBC. So first input is we record is a seismic zone. This should be specified in a technical specification or should be given by the customer. Next one is we need to find out the seismic zone factor. This is as per table 16 of I UBC 1997. For that we need to go to page number 30. So in the right hand side of PDF you can see table 16I which is showing the zone factor. So we can select now. If it is 2A means it is showing 0.15. This is as per the table 16I. And again in the Excel sheet if we are selecting 2B it is 0.2. Similar like for 3 it is showing 0.3. Next input we need to provide is a soil profile. That soil profile generally we can able to find out from the geotechnical report. Whereas this soil classifications are listed here in the table 16J in the right hand side, that is page 30. SA is hard rock, SP is rock, SC is very dense soil and soft rock, ST is a stiff soil profile, SC is a soft soil profile, whereas SF can be evaluated based upon the soil site conditions. So we can select ST for our demonstration purpose. Next one is seismic occupancy category. For that we need to refer table 16K which is in the same page. There are 5 numbers of occupancy category. You can see in the right hand side PDF file. 1 essential facilities, 2 hazardous facilities, 3 special occupancy structures, 4 standard occupancy structures, 5 miscellaneous structures. The detailed description of these occupancy categories are listed here in the next column, like group 1, group H, group A, all structures group U likewise. So similar like in the next column if you see seismic importance factor I and seismic importance factor IP are provided corresponding to the seismic occupancy category. So this table also listed in the right hand side of tab of Excel sheet. So this is a table. So if for our calculation if I am selecting this essential facilities type of seismic occupancy category, then the factor of IP is, that is important factor of seismic, is 1.5. So we can consider our occupancy category as hazardous facilities, the second category. So after selecting these 3 gray color highlighted input, this table six point 16Q will give you the value of seismic coefficient Ca. So for our case seismic zone 0.3 and ST soil profile we are getting 0.36 as a factor. So for this table 16 Q we need to refer page number 34. So here in the right hand side you can see in the PDF file table 16Q. So for all seismic zones seismic zone factor 0.075, that is seismic zone 1, and seismic zone 2, 2A, which is 0.15, and for 2B it is 0.2, and for seismic zone 3 it is 0.3, and seismic zone 4 it is, so all the 0.4, so all this value of CA are listed in this table based upon the soil profile. So in our case we had selected the seismic zone as 3. Suppose if the seismic zone is 4, we need to calculate another value called near source factor. So this near source factor is mainly applicable only for seismic zone 4. So for that again we need two numbers of input to find seismic coefficient CA, because in this table if you see for seismic zone factor 0.4, the value of CA for each soil profile is mentioned as 0.32 into Na, or 0.4 into Na, and 0.4 into Na, 0.44 Na, or 0.36 Na. So this Na factor we need to calculate if the seismic zone is falls under 4. So this Na is nothing but it is a near source factor which is defined in table 16S of UBC 1997. For that we need to refer page number 35, it is a next page. So here you can see in the table 16S, based upon the seismic source type. So this is seismic source type ABC definition also provided in the below table. Under table 16U you can see this. A means it is a faults that are capable of providing large magnitude events and that have a high rate of seismic activity. So C is a faults that are not capable of producing large magnitude earthquakes and that have a relatively low rate of seismic activity. And seismic source type B means all faults other than type A and C. In detail you can see the maximum moment magnitude. For A it should be M, magnitude is greater than or equal to 7. For source type C, magnitude should be less than 6.5. If the magnitude is in between this 6.5 and 7, then it should be categorized as B source type. So once after selecting this source type, for our case we can select this as A, and for closest distance to no seismic we need to refer the same table 16S. In that, in order to find the Na value, that is near source factor, so we need to select the closest distance. Suppose I am selecting less than 2 meter, means it means the seismic magnitude is very closer to the site. So then the factor is 1.5. Obviously the seismic load also get increased. So if it is 5, means it is a medium. Suppose if it is greater than or equal to 10 kilometer, then you will get optimized seismic lateral forces, as the factor for near source is 1. So we can consider greater than or equal to 10 kilometer. So then the seismic coefficient Ca is 0.44. Suppose if it is 5, means it is 0.588. So it is calculated based upon the table which are listed here. So this n value also get changed according to the seismic zone 4 and the seismic source type and the closest distance to no seismic which we had selected. So next one is value of horizontal force factors. For that we need to refer table 16O. page number 33. So in this, let we consider chimney stacks and truss towers supported on or projected above the roof, laterally braced or anchored to the structural frame or at or above their centers of mass. For that, AP value is 1 and RP value is 3. So we are entering here the same value. Total vertical load WP we can assume as 10 kilonewton, as this is a demonstration alone, and the total height we can assume as 10 meter. Seismic effective acting location we can consider as center of axis of height. So it is height divided by 2, so that hx equal to 10 divided by 5. We can also have any height where we need to find the seismic lateral force. We can also enter 2 meter or 4 meter. Up to 10 meter we can enter, as the height, total height we are having is 10 meter. Then finally the total design lateral force FP, we need to apply this formula. This formula we can find out in section 1632 of UBC 1996, page 18 to be referred. So here in the right hand side you can see the highlighted green color. This is a formula to find out the design total lateral force. FP equal to AP into CA into IP divided by RP into 1 plus 3 HX by HR into WP. WP is the weight, total weight. We consider here as a 10 kilonewton. So we have all the values. AP value is 1, CA value is 0.528, IP is important factor we are having as 1.5, HX is 10 meter, HR is 10 meter, HX is 5 meter, WP is 10 kilonewton we had assumed, RP is 3. And also we need to check the limitation of design lateral force which we had calculated. So this 6.6 is actual load which we had calculated using this formula, and UBC 1997 also defined in class 1632.2, whereas this calculated actual total lateral force should not exceed 4 CA IP WP, which is a maximum lateral force, and it should not even less than 0.7 CA IP WP. So we need to check this also. So for our maximum lateral forces, it is coming 31.68, and the minimum is coming 5.54 kilonewton. But in our case, that actual design lateral force is 6.6 kilonewton, so which is within the limit. So this is a summary of this video. So now we had calculated the design lateral forces. We will look more related videos. Look description for more related videos. Thank you.